In this episode of M Squared M Cubed or 2, Mrs. M's Math to the Masses, in a minute or two, we'll keep working through theoretical probability, looking at simple events and the complement of an event, calculating those values. So this says probability is the measure of how likely an event is to occur. This is rehashing what we've done in another video. The set of all possible outcomes is called the sample space. And remember, that always goes in our denominator. So I'll write that in. Remember, push pause if you want to write some notes of your own. For equally likely outcomes, the theoretical probability of an event, written as uppercase P and then in parenthesis uppercase E, probability of the event, is the ratio is a fraction, right? We're just comparing two values. The ratio of the number of favorable outcomes over or to the total number of outcomes possible. So we're going to do some examples. Let's come look at these first couple where it says you have a jar and it contains 32 red marbles and 28 blue marbles. So total there are 60 marbles when you add those two numbers together. So that's your denominator. In the numerator you're going to put, since the question is, what is the probability that randomly selected marble is red? Well, there's only 32 of the 60 that are red. So you immediately take and reduce that, and it becomes, look at the right thing, it becomes 8 over 15, which in decimal form is equal to 0.53, and we multiply by 100, we get approximately 53%. So this right here is the work to support that answer. The next question says, a letter in the word restoration is randomly selected. What is the probability of selecting a vowel? So we've got 11 total letters in the word. And we have 5 of the 11 which are vowels. That would then become 0.45 as a decimal, which is about 45% when you multiply by 100. So depending if they wanted the answer as a fraction or ratio, that's your first answer, 5 over 11, 0.45, or a 45% chance. Next set of examples. A day in the month of January is randomly selected. What is the probability of selecting an odd number? Well, there's 31 total days. That's your denominator. And your odd numbers are 1 through 31 as noted here, so let's count them. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. 16 out of the 31 are odd numbers. So there's your answer as a ratio, 16 out of 31 chance. In decimals, that would be 0.52. When you multiply times 100, that's about 52% chance of selecting an odd day out of all the days. The next example says one dice is rolled. What is the probability that you roll an even number? So remember, on any die, there are 6 possible rolls you could get. That's your total. 3 of them are even. That's a 1 out of 2 chance when you reduce your fraction, which is equal to a 0.5, a 50% chance, or 0.5, which is about 50% when you multiply times 100. Another example, it's probably getting to where you don't need these anymore, but feel free to keep looking. What is the probability of drawing a heart or a club from a standard deck of cards? Well, you have to remember, it's written here at the bottom, a standard deck always has 52 total cards in it. Each suit has 13 cards. So since they're doing heart and club, that's 13 plus 13, or 26 out of 52. Again, that fraction reduces to 1/2, which equals 0.5, which is about a 50% chance. It's absolutely a 50% chance. There's no rounding needed. Okay, so this all here is the answer. This all here was an answer, and all 3 of these were an answer, depending if they ask for the fraction or ratio, the decimal, or the percentage. So then we have a sample here. It says there's 8 books lettered A through H on the shelf. If Scott randomly chose a book, looks like we have a little typo here, what is the probability that he chooses books A or B? So A or B, it's A over H, and it's A or B. Okay, so A is one choice, B is another. That's 2 elements it could be out of the total of 8 that you have. That reduces to 1 over 4, which becomes 0.25, which gives you 25% chance. So your best answers would start right here. 1/4, 1 out of 4 chance, a 0.25 chance, or a 25% chance. That's simple event calculations. Now let's look at complement of an event, just in terms of running numbers. We've already discussed it as a concept. So the first thing to consider is a complement of an event, as we discussed earlier, is the probability of the event not happening. Since the sum of all possibilities in the sample space is 1, because 100% chance is 1 over 1, the probability of an event not happening is 1 minus the event happening. So here, example 7 says the probability that it will snow tomorrow is a 7 out of 20 chance. What is the probability that will not snow? Well, that means 20 is still our total, but 20 minus 7 is your numerator. So you have 13 over 20, which becomes 0.65, which is a 65% chance. Okay. Sample 8. Let's go with a month of the year is randomly selected. What is the probability of getting a month that does not begin with the letter A? Okay, so there are 12 total months in the year, and there's 2 that begin with A. So 12 minus 2 would give us all the choices that don't begin. So that's 10 over 12, which reduces to 5 over 6, a 5 in 6 chance that you would not get a month that starts with A. So this is equal to 0.83, 83%. Right there. Move to the example number 9. If the spinner to the left, here's this picture, is spun, find the probability that it lands on a number that is not even. Okay, so we have 16 total chances, and we have 16 minus 8 that could happen will give us 8 over 16 that it would not be even. So that reduces to 1/2, which reduces to 0.5, which is a 50% chance. And for our last example, 2 dice are rolled. What is the probability of not getting doubles? Okay, so doubles are 6 chances. So we're saying 1 minus 6 out of 36 chances would be doubles, so it's 1 minus that. So we end up with 1 minus 1/6, reduce that fraction, which means there's a 5/6 chance of not getting doubles, which is equal to 0.83, which is about an 83% chance of not getting doubles. There are some examples on theoretical probability, simple events, the probability of one event, and complement of an event.